Pluto, that faraway and kinda hidden planet, used to be considered one of ours. But recently, some big-shot astrophysicists like Neil deGrasse Tyson and Miyoku have gotten people talking about it again. They're saying that this icy planet might be heading for a crash with Neptune. How could that even happen? And what would the fallout be from something so huge? Are we seeing something totally weird and out of the blue, or is there more to this possible space disaster? Let's check out what could happen if Pluto and Neptune actually collided. So, Pluto, it was a planet, then it wasn't, now it's a dwarf planet. Either way, people are still really interested in it. These experts are now suggesting that Pluto's orbit is getting way too close to Neptune's. That's why Tyson and Miyoku are warning us that these two could smash into each other. Could that be a danger to Earth? But how could they even hit? Well, Pluto's trip around the Sun is different from all the other planets. It takes 248 years to make just one lap. Since we found it in 1930, it hasn't even finished a single trip. Plus, its orbit is super oval-shaped, not round like the other planets. And get this, it's tilted. It's at a 17-degree angle compared to the rest of the solar system. That makes its path a lot more wacky than the other planets. Here's a crazy part. For about 20 years during each orbit, Pluto actually gets closer to the Sun than Neptune. So, why haven't they bumped into each other yet? The answer has to do with gravity from other planets. Once Pluto was spotted, astronomers tried to figure out its weird orbit. Unlike the other planets, Pluto's orbit is at a steep angle and really oddly shaped. The puzzle got even harder when they realized its path crosses Neptune's. But even with that, Pluto's orbit is still stable. Think of it like trying to guess where Pluto, Neptune, and the Sun will be based on where they started and how they pull on each other. The stability of all the planets' paths depends on something called non-concurrent libration. For Pluto and Neptune, it means that when Pluto crosses Neptune's orbit, they're always at least 90 degrees apart. That space keeps them from hitting. Another thing, orbital precession. It's like a slow, up and down wobble of a planet's orbit. For Pluto, it means that when it's closest to Neptune, or any big planet, it's way above their orbital path. That's another safety net against crashes. Also, there's this VSK wobbling thing. It's named after some researchers who studied how planets pull on each other. This wobble explains why Pluto's orbit seems wild but stays steady over time. The gravitational tug-of-war between Pluto, Neptune, and the Sun keeps Pluto's orbit fairly smooth, even though it's oddly shaped. The VSK wobbling shows that even in crazy situations, there are patterns and forces that keep things stable. This three-body problem is key to understanding Pluto's orbit, its relationship with Neptune, and how other faraway objects act in our solar system. In the late 1980s, some computer simulations showed that Pluto's orbit, even with those stabilizing forces, is actually pretty unpredictable. Tiny changes at the start could make a big difference in where it goes over hundreds of years. Still, these simulations also showed that Pluto's orbit stays stable for millions or billions of years. To really get how Pluto and Neptune work together, you have to think about the gravity from the giant outer planets, like Neptune, Jupiter, and Saturn. Neptune's impact is huge because it controls Pluto's orbit in a special way. For every 2 laps Pluto makes around the Sun, Neptune makes 3. This keeps Pluto's orbit stable. But Neptune isn't the only one involved. Jupiter's massive gravity also helps keep Pluto on track, and Saturn adds to the mix. These forces all work together to make sure Pluto stays on a steady path for maybe millions of years, keeping it away from Neptune. Without these forces, the solar system would be way more chaotic, with planets possibly crashing into each other or getting thrown out completely. That would be a disaster. The possibility of Pluto and Neptune colliding in the future shows how complex space stuff really is, and why it's so crucial to study how stable orbits are. By understanding these details, we can better understand how the solar system works, the role of gravity, and how distant objects behave. Even though Pluto's orbit might seem crazy at first, it proves that there's a delicate balance of forces that keeps it in place. Exploring space often leads to surprises, and Pluto's weird orbit is a great example of how mysterious the cosmos can be. The idea of orbital chaos shows how a planet's path can be super sensitive to where it starts. For Pluto, even small changes in its position or speed could totally change its long-term orbit. Computer simulations are a big help in studying this. They model how Pluto and other objects like Neptune pull on each other through gravity. These simulations show how even the tiniest changes can have a huge impact on where Pluto ends up. Even though Pluto's orbit is stabilized by things like vibration and precession, simulations also show that it's far from consistent. Tiny changes at the beginning can lead to very different results, making it really tough to predict where it'll go in the long run. But despite all this chaos, Pluto's orbit stays fairly stable over billions of years, suggesting that even in the middle of chaos, there's some kind of order to its movement around the Sun. Predicting where planets will go, especially ones with weird orbits like Pluto, is really difficult. The unpredictability of these systems means that any long-term guess is full of uncertainty. Computer models help us understand and predict, but they depend on super precise starting info. Even a tiny error can lead to very different outcomes, making it hard to know Pluto's future path for sure. Besides the chaotic nature of orbits, Pluto's story reminds us that the universe is always changing. Even with all we've learned about space, Pluto shows how much we still have to figure out. Understanding how the giant planets affect Pluto's orbit gives us important clues about the bigger picture of the solar system, showing how the position of each planet can really impact the path and stability of others. So, why are these astrophysicists worried about a possible crash between Pluto and Neptune, even with all these stabilizing forces? Neil deGrasse Tyson, who had a big part in reclassifying Pluto as a dwarf planet, gives us a good perspective on the mysteries of our solar system, including what might happen to Pluto. Tyson has helped change how people see Pluto and its place in the solar system. Tyson sees Pluto's reclassification not as bad, but as a necessary adjustment based on what we're learning about space. His approach is all about constant and fresh. He sees the complexity of orbits like Pluto's as proof that there's so much more to the universe that we yet to explore. Even though Tyson is optimistic, his views on a possible crash suggest that there are still a lot of questions. Will Pluto hit Neptune, or is it just a temporary scare? Only time and more research will tell. For now, we're left wondering just how much we don't know about our own solar system. The idea of a potential collision makes us want to examine the mysteries of the universe even more, and questions what we know about how planets act. A crash between Pluto and Neptune would have major effects on how we understand planetary behavior. To understand the dynamics of a possible impact, we must consider the characteristics of both planets. Pluto, a dwarf planet, contains many elements and compounds in a frozen state thanks to how cold the outer solar system is. Its surface is covered with nitrogen ice and its atmosphere is primarily made up of nitrogen, methane, and carbon monoxide. Neptune, on the other hand, is a massive gas giant, consists mainly of hydrogen, helium, and other lighter elements with a deep, dense atmosphere. A crash between these two vastly different bodies would undoubtedly have profound effects on both planets by potentially creating an event that could be seen from vast cosmic distances. Neptune's gravity is not the only stabilizing force. Jupiter, the largest planet, also exerts a gravitational pull contributing to Pluto's stable orbit. Saturn's gravitational situation makes it unlikely that a collision between Pluto and Neptune happens. While Neptune's gravity plays a big part in stabilizing Pluto's orbit, the complex forces of other planets like Jupiter and Saturn further keep Pluto's path in check. Yet, the situation between Pluto and Neptune is not as simple. The gravitational resonance between the two planets, where Pluto completes 2 orbits for every 3 Neptune completes, creates a natural barrier that prevents them from colliding. The future of this balance isn't guaranteed. Small shifts in planets' positions or velocities could disrupt this resonance. These shifts could be triggered for external forces like gravitational influence. Continued study and observation are essential as technology gets better. People refine the models and understand the dynamics in the distant objects. New data could give the balance that keeps Pluto and Neptune from collapsing. The possibility of an undiscovered object influence can be a key factor in this study. The hypothetical planet, which is referred to as Planet 9, is believed to be in the far reaches of the solar system. Some scientists speculated that its gravitational pull could alter the orbits of Pluto by destabilizing their positions. Beside the gravitational forces, there is the broad context of how the solar system is evolving. The Sun is the dominant force of the system, gradually losing mass. Objects such as comets or other small bodies has their own gravitational forces.